You know, right now, as you're sitting there, there is a war going on inside your body. It's a microscopic battlefield, totally invisible, where your immune system is in a constant fight against invaders. It's this incredible story of defense, of recognition, and of memory, all happening on a scale that's just hard to even wrap your head around. So let's dive in.
It's a pretty wild question when you think about it, isn't it? I mean, how does this incredibly complex system make trillions of the right calls every single day? How does it know to zap a dangerous virus, but, leave the friendly bacteria in your gut completely alone? The answer is all in this secret molecular language of shapes and signals.
So, here's how we're going to break it all down. First up, we'll meet the invaders, the foes. Then, we'll introduce the body's elite force, its defenders, and take a look at the anatomy of their perfect weapons. We'll also see how they have specialized squads for different threats. And finally, we'll get to the most incredible part, how our body actually learns from every single battle.
All right, so every good story needs a villain, and ours begins with them, the foreign substances that ring the alarm bells in our immune system. In the world of immunology, we call these guys antigens. Okay, so what is an antigen really? The easiest way to think about it is like a molecular fingerprint. It could be a piece of a virus, a part of a bacterium, some pollen, you name it. It's basically any substance that your immune system takes one look at and goes, whoa, hold on, you're not from around here. So how does the body actually read this fingerprint? Well, it all comes down to this really elegant system we call lock and key. See, every antigen has a unique shape on its surface, and we call that specific part the epitope. You can think of the epitope as the lock. The immune system's whole job is to design one and only one perfect key that will fit it. But here's the thing, not all invaders set off the same level of alarm. Some are big and loud and immediately start a fight. Others are a little more sneaky. Turns out, when it comes to provoking your immune system, size and complexity matter a lot. And this brings us to two really important ideas: immunogens versus haptens. Immunogens are the big guys. They're large, complex, and can kick off a full-blown immune response all by themselves. But then you have haptens. These are tiny molecules that are too small to start a fight on their own. Think about penicillin. For most of us, no big deal. But in some people, that tiny penicillin molecule latches onto one of our own body's proteins. All of a sudden, this new big combo looks like a massive threat, and bam! The immune system attacks, and you get an allergic reaction. Okay, so we've met the invaders, the antigens. Now it's time to meet the heroes of our story, the body's elite defenders, the microscopic special forces designed to hunt down and neutralize these very specific threats. Let's meet the antibodies. Right, so an antibody, you might also hear it called an immunoglobulin, or just IG for short, is this incredible Y-shaped protein. It's made by a type of immune cell called a plasma cell, and its entire mission in life is to identify and take out foreign invaders with stunning precision. And here it is, the other half of that lock and key system. If the antigen has the lock, then the very tips of this Y-shaped antibody, well, that's the key. This is the antigen binding site, and it's so specific, it's mind-boggling. An antibody designed for, say, the chickenpox virus won't even look twice at the flu virus. So what do they actually do once they've locked on? Well, they've got a three-part playbook. First, they can just block the invader, physically getting in the way so it can't harm our cells. Second, they tag it. They basically cover the pathogen, slapping a giant kick-me sign on it for other immune cells to find and gobble up. And third, they can trigger a chain reaction to destroy the invader directly, activating other proteins that literally punch holes in it. This is all pretty incredible, right? But to really get how they pull all this off, we've got to zoom in and take a look at how these amazing little weapons are actually built. So let's get up close and personal. This is the basic blueprint of an antibody. You can see that classic Y shape, and it's actually built from 4 different protein chains, all stuck together. It might look a little complicated, but trust me, every single piece of this thing has a critical job to do. All right, let's break this structure down. The main body of the Y is made of 2 big, identical, heavy chains. Attached to the outside of those are 2 smaller, light chains. But the real magic, the business end, is right up here at the tips. That's called the variable region, and that's the part that's totally unique. That's the key for the lock. The stem of the Y, on the other hand, is the constant region, and that part is like the instruction manual that tells the rest of the immune system what to do next. And that instruction manual part is super important because it leads us to our next point. There isn't just one type of antibody. Nope, Based on that constant region, they're sorted into 5 specialized squads or classes, each one designed for a different kind of mission.
And they don't all look the same either. Some are lone wolves, just a single Y-shaped unit. We call that a monomer. Others team up in pairs, which are called dimers. And then you have the real beast, IgM, which forms this massive 5-unit superweapon called a pentamer. It's got 10 arms to grab onto invaders. So here they are, the 5 main classes. You've got IgG, that's your main soldier in the blood, and it's the only one that can cross the placenta to protect a baby. Then there's the giant IgM, always the first responder on the scene of a new infection. And you've got IgA, which acts like the security guard for your gut and lungs. See? Each one has its own turf and its own special job.
Let's make this really concrete with an example pretty much everyone knows: allergies. The antibody responsible for all that sneezing and itching, that's IgE. When you breathe in something like pollen, your body can make IgE antibodies specifically for that pollen. These antibodies then go and sit on special cells called mast cells. So the next time you're around that pollen, it binds to the IgE, and that tells the mast cell to basically explode with histamine. And that's what causes all the misery.
Okay, but perhaps the most mind-blowing part of this whole story isn't just the battle itself. It's the fact that the immune system remembers. It keeps a detailed record of every enemy it's ever faced, so it's ready for them next time. So check this out. This graph shows what happens the very first time you get sick with something new. This is the primary response. See that first little bump? That's IgM, the first responder, showing up quick. Then, a little later, you get a bigger, more powerful wave of the heavy hitter, IgG. But the whole process takes time, maybe a week or two. And that's the period when you actually feel sick. But here's where the magic is. The second time you encounter that same bug, oh, it is a whole different ballgame. Look at that response. It is so much faster, so much bigger, and way, way more powerful. The system recognizes the enemy instantly and just unleashes this devastating flood of IgG. The invader gets wiped out before you even know it was there. That is immune memory. So what's the bottom line here? It's simple. Your immune system doesn't just fight, it learns. It builds this incredible library of every bad guy it's ever defeated, so it's never caught off guard by the same one twice. This is literally the entire principle behind how vaccines give us long-lasting immunity. All right, let's do a quick recap of the whole battle plan. Antigens are the invaders, the things that set off the alarm. Antibodies are your body's special forces, precision engineered to take them out. That lock and key fit is absolutely critical for them to know who to target. And the coolest part? The immune system remembers, so it's always getting smarter and stronger with every fight. But that brings up one last, really fascinating question. If our immune system is this smart, this powerful, with such an amazing memory, why does it mess up sometimes? Why do we have things like allergies, where it goes to war against harmless dust, or even worse, autoimmune diseases, where it tragically attacks our own cells? Well, that's a whole other can of worms and a story for another time.